I thought was a very exciting session. Lots of very interesting things. Jens, I'm glad to see you can still be here. That's really good. I think Krobus is in transit, and he will be joining us with audio only. Uh, yes, and I just wonder if oh no, there you oh no, there you are. Okay. And
Sorry, Magic.
yeah, and Derek, if you also there, it would be good to have you as well. And yeah, I think this was a very interesting session indeed. I have lots of questions, but I would open first for the audience if the audience has questions. Chris, I remember you had a question. If you want to ask it now, there you go, Chris. Yeah.
I thank you to all the presentations. Absolutely amazing work. I suppose I've got a question. Perhaps it's mostly Emma and Dirk, which is perhaps it's more that Emma identifies all of the problems that AEC has as a sector in adopting the standards which have been well established, not just in oil and gas, but also in industrialized manufacturing. And just a remark, so there is a question at the end of this, but just a remark that the STEP file format also uses Express. It uses the Express language to data model inside of STEP. And one of the interesting parallels, and I don't know if Emma wants to elaborate on this, is that in industrialized manufacturing, there is a standard for the quality information framework. And you end up with a file, a .qif file that is across all of the information model in Emma's slide. So right at the start, passed on to the manufacturer, passed on to the installer, and potentially passed on to O&M manuals. And that QIF file can then be added to and fed back to the designer in a new project that might have similar functional and performance requirements. Uses XML, which it sounds like IFC and the other standards are sort of migrating towards as a data model. So QIF, Quality Information Framework, uses schemas. There's a whole collection of schemas for the different parts of it. But so where I was going with all of this is that with Dirk's presentation, if you ever try to use these standards, the problem always seems to be in construction that it's so fragmented. So trying to get the supplier to give you a high quality model that the whole of the process will trust. In other words, they might use the dictionary, they might fill in all of the fields. My pump is manufactured by Grundfos, it's this specification, it has this capacity, I expect it to last this number of hours in use, it's maximum temperature, minimum temperature, operating temperature, all of that. You can try to put the information in, but it gets lost as it sort of moves through the chain of information exchange from the designer and indeed all of the different actors in a construction design team, because it's not just one, usually isn't just one consultant. There's a structures, there's an M&E, there's an architecture trying to coordinate all of the different sources of information. And the moment that moves on to the next step, they sort of throw everything away. The contractor thinks, no, I'm not taking all that information. I'm going to start again. And you lose so much in that. I just wondered, I don't know if Dirk or Emma wants to jump in to just say how this is different in oil and gas. Is there a much more vertically integrated source of authorship as well as progression from each step, from design to tendering to starting to do construction to commissioning to operations to end of service life dismantling and potential material recovery and reuse, and then an audit trail, the sort of ephemeral golden thread that then can be used by the next generation of the designers working on a new project that again has similar characteristics. There's a question in all of that, which is basically what is the trouble? Well, why is it so difficult to keep the data portable? It isn't a lack of frameworks. They exist at different scales of detail as well as time. It's more that I think there's a sort of, you might talk about a skill shortage. I think there might also be an awareness shortage that all of the parties in a way have a vested interest in having a good quality of data, but it seems to be this real frustration and struggle professionally as well as an industry to keep the data in a high enough efficacy that it maintains its value as it passes from stakeholder to stakeholder.
Yes, I'll come into that. Yeah, so there is so many issues, and I put some on my slide, and you rightly said about like the different stakeholders and everything, and for me it's not necessarily even a data or information issue. It's procurement, and it's something else I talk about and champion, because for me, until we actually solve that, the information management side will always be hitting its head against a brick wall. At the moment, without certain procurement methods like design and build, for instance, it just doesn't work with information management for the reasons you've said. You create a load of information, and then generally what happens, that gets scrapped and started again, and nothing gets carried through, and just the way we pass on risk as well, it doesn't work. And a few years ago, I was really lucky to work on the first integrated project insurance project here in the UK. Back in 2015, and that was completely, we threw the rule book out with terms of construction. It was one flat project structure, one bank account, one project insurance, and that has a massive impact on this type of stuff, because that changes our behaviours. It's less adversarial. I was always told that we actually produce 20% of information on projects that's not even needed, but it's only needed for arse covering. And it's that fundamental structure of how a project operates is fighting against the flow of information. And for me, until we sort that out, like I said, it is always going to be a struggle. So that kind of is the fundamental thing for me. In terms of oil and gas, I don't know how those projects operate, so I'm not an expert in oil and gas.
Chris, can I add a quick comment here? Nice to see you. Yeah. So I presented something which is very much about the future way of work in interfaces. To have it back in understanding is where we are sitting with OpenUSD, and I think it's the alliance of OpenUSD being formed. Most of what I do at the moment is looking at semiconductor fabrication. The amount of data per machine is probably more than what a building consumes, and we have hundreds of these machines on the floor. And one of the things that we are working on right now are two connection sites: the actual geometry representation that has the data containers in it, as well as the data being fed from various sources, be that IoT through MQTT or whatever the case is, or actually through synthetic data, which is the other very important part of this, because synthetic data allows us to predict things that's going to go wrong inside of these spaces. What we're working on is this divide between your generation of your asset or your model that we don't know what it's going to do in the future or the demand of it in the future, but that's the scalable developer side of it. And then the structure of how these things are assembled, which is more fixed. We're putting a machine onto a floor, we're putting a door into a facade, whatever the case is, that's a fixed aspect. But what we want that door to be doing in the future might not be knowledgeable yet. We don't know that yet. And how we're working on that is trying to prescribe some structure of what that data sits as a placement model, but allowing the freedom to start augmenting that. But the biggest part of that is that an architect can place that model as a simple cube, and by the time it gets to the fabricator, that could be a manufacturing model that replacing the cube, but the asset and the structure around the asset remains, and its location in the building remains. It's how we're augmenting that data to move forward, because every sect has its new demands. There's no translation. It's augmenting and growing this asset to be able to an operational asset. That's how we look at it in kind of factory aspect. And it's because there are so many different disciplines as well, respected into these singular structures and buildings. So just a little pointer on that. And it's an interesting development at the moment.
Right. And Corbus, how do you see this relationship or this nexus between USD and IFC happening then? Is
That's great.
mutually beneficial, or what is going to happen?
Absolutely. I mean, there's no replacement. There has to be some, the biggest divider here, there has to be some method now, talking about scalability, because we are moving into a state of compute and functions that we don't know what's going to happen next year. IFC can be fully consumed within USD with all data and properties. I think there's an incredible stack of information and knowledge that's contained between this in the schema of IFC itself. IFC, it's very, very important. But I cannot simulate or function anything further within IFC. It is a container or a schema that holds a very specific domain. And I think one of the things that I'm pushing right now is that we sit within AEC, looking at AEC problems, trying to solve AEC problems, where we should take from other industries and ingest in a very natural way, in a very, very natural way. So, there's applications that just don't work together. So we need to get into an agnostic space, and IFC is one of those, and USDs is kind of the bigger, almost in a way, umbrella that I see that allows us that freedom to take on what's coming our way. Really to scale it. That's the big thing. So yeah, we ingest IFC data, everything. I mean, we take a model from Revit, for example, as well. We can take all the data across, and the beauty about it is we can augment the data. So we can give these things physical properties or AI related functionalities or anything like that. So absolutely, IFC is very important. It's a very, very good schema.
So I think, Derek, you were going to say something, but also Chris has a follow-up question, I think.
Maybe just briefly, because I think this observation we have as well, that why is this a problem? It seems as if digitalization and information management has been neglected so far. And maybe the reason for why change is so slow is that many different stakeholders are involved, and they are seeking to protect their competitive advantage. So topic IPR. And also we are dealing with capital intensive, long lasting assets that are slowly changing. And somewhere there must be the reason. So we are wondering as well.
Our industry is very short-term and reactive, and there is a massive lack of education in regards to information and data. We're very visual. We see software. That's what we're drawn towards, and we get sold software that solves all of our problems. And that's largely what's happened over the past 40 years. And it's only kind of now we're realizing actually that's not solving anything. We're getting more of a mess every single year with interoperability. It's because we're not actually going to the basics and actually under the hood of the software and actually looking at what the information is doing. And again, that, like I said, it goes back down to basic digital and information literacy.
Right, and Chris.
But just to extend what Emma said, it's short-term thinking, but the irony is, compared to almost all of these other industries, it's got the longest asset time. So you make a decision, and it's there for 150 years. I mean, you hope it lasts forever if it's a really good building, and if it isn't, you want it flattened last week. My sort of, I think what's really interesting, if I may say so, with all of these, is that AI is really starting to poke at the potential that there is an Uber language needed. And I say this because, again, sort of extending what Emma's already said about information, is that it's useful at different scales of abstraction for the same thing. So like if you think about the presentation on the log, the point is that the logs are all different. You go out into a forest and you look around and every single tree is different. Yet in terms of typology, they often are a branch. There's a stem and then it breaks down into smaller branches. So there are typologies that you can extract. And at one level of abstraction, as the paper showed, that's enough. You've got your 3 support points in your model and you work out from that. When it comes to producing a cutting pattern, to work hold one specific branch and figure out the kerf width of your bandsaw, or if it's a chainsaw, and the allowable deviation that you have for cutting it in order that you can join at the scale of the tree, it's a different level of information, but it also uses all of these same issues. So quality information framework, as I'll talk about tomorrow, deals with model-based definitions that are at the really small scale of the manufacturing requirements. So there are one level of abstraction into the detail of the geometry, because the geometry in your model is fantastic. It's mathematically precise. A square is a square, but you go out into a workshop and real materials are made with tolerances. They can be bigger and they can be smaller, and they're often not flat. So they have deviations in surface flatness and so on. And that you can capture in production or product manufacturing information. But you don't need that for every part of a particular product. You only need it projected where it's functionally critical. And that's one layer which works only at that layer. Once you start to zoom out, the level of abstraction starts to rise. And you think about Cobus's example of the whole of the sky, the whole of a high-rise building, you're dealing with one side of facade. That's not necessarily so relevant. But the point is that there is a schema in the instance of QIF which deals with that level of detail. And as you think about Emma's information model as a sort of horizontal line, it occupies particular verticals on it, but it needs to be coupled at different times all along the process. It's usually concentrated on the design moving into manufacturing, and then it's sort of fixed until you get things that might cause problems and be failures and be reported later on, which gets plugged into the model and sent back to the process parameters. So my point is that it's almost like there is going to be at some stage an Uber data structure that puts all of these separate data structures in terms of the model, depending upon the scale of abstraction or the level of abstraction, and it's often spatial. Thinking about a whole city block to do a sun path analysis, thinking about the organizational principles of structure, facade, thinking about an individual facade element in terms of how it's manufactured to fit to the secondary structure or tertiary structure behind it, or other way around rather, secondary structure, primary structure behind it, and then the operational aspects, and then zooming out again to thinking about the decisions that you made at that small scale as they impact the decision that you made globally. And that's where I think AI will really start to bring those different things together. So it's almost like an ontology of ontologies is needed.
Yeah,
where QIF, IFC, all of these different worlds map well enough that you can navigate decision making between them.
Yes, yeah, that's a very interesting point. Jens, you have your hand up.
Yeah, sort of. So I found a lot of interesting things in this morning's talk and in this discussion, and I kind of wish we were all together in the same room and we could sort of
Yeah.
gather around a whiteboard or something and discuss, sort of hash out ideas and things. But by analogy, with my funding body hat, when we fund a project, you must have a data management plan. So the analogy is, well, let's sort of say we could fund a building, like we ask you to build a building and we give you money to do that. When we fund a project, you must have a data management plan, which says what you will do with the data. And ideally, with public funding, like taxpayers and stuff, that has to be open at some point. You can embargo it while you work on it and publish your publications, but then you must have open data. And particularly for the very large instruments that we fund, there must be a public benefit to that, like for all of humanity, ideally. But we also see scenarios where we have competitors come together, like in Credo, where you have the competing companies because there's just too much data. Pharmaceutical companies come together and they have to share data because of next generation sequencing, generating too large volumes of data. But they're still competitors, but they can work together at some level. So things like Pistoia Alliance has formed a natural collaboration of pharmaceutical companies to work together to solve their problems and yet remain competitive and distinct companies. So I think going back to buildings, one could perhaps do something at a regulatory level, saying you must have data sets available for, I don't know, inspections or something. I'm now thinking out loud mode, or you find competitors working together because of the, so you have several companies building stuff out in the real world, but they can work together at some level on infrastructure resilience, for example, urban planning. So bring stuff together at a higher level.
Yes, and I believe also ontologies in biomedical, they are very open, they are very interoperable, right? You have lots of domain specific.
But it took a culture change to get there.
Yeah, yes.
Right? And it's a bit, as a funding body, it's a bit carrot and stick, that we if you publish your data sets, we recognize that as a publication, so you get academic credit for that. But on the other hand, when we give you money, we expect you to publish your stuff, like to make it available. So the data should support your publications as well. So you can imagine a scenario where somebody takes a policy decision on building greenfield land or whatever, new housing. But the decision behind that, the urban planning, where they're planning permissions and the higher level government stuff, that should have data beneath it as a foundation for that decision. How was that decision made? How sometimes you find between Whitehall and the local government, you find disagreements about the use of land, and somehow that data set beneath that should be auditable, you would think, and ideally published, perhaps.
Glad you mentioned cultural change. I think I'm at a point of once you've seen it, you can't unsee it. So that's where I sit.
And Derek, I wonder if you have something to say about ontologies in other verticals and how this could inform what you've been discussing and the ontologies being developed for the construction industry and for the built environment, for smart cities and so on.
So we have been looking at different representation formats as well, including Express and STEP was mentioned. And we do not go that route. We choose a logic-based language as a modeling language to describe the real world. And for that, we chose W3C's web ontology language OWL, which is essentially based on a logical formalism, description logic called Schroik. And OWL2 is based on Schroik. And what does OWL do, or what do description logics do? They categorize everything into classes, individuals, and properties which connect individuals together. So you need to, essentially you're forced to take your domain or your real world apart and model it in terms of this modeling language. So everything needs to become either a class, individual, or property. And then using this logical language, you are very clear about your model, and it allows you to reason about your model. So you can draw rational conclusions from your represented knowledge. And that we find is not easily done, or at least not readily available with the other representation formalisms. So there is value in viewing the world via a logic eye, so to speak.
Yes, yeah. And Emma, I was going to ask, because of the IFC evolution and because of what Cobus just said, cultural change and also the logical insights you can have in ontologies and so forth. How do you see IFC being used for asset information management systems, and how do we deal with the legacy that we have? For example, in Transport for London, there is a legacy of using certain databases in the Maximus, Ellipse, and so on. Is IFC going to change all of that, or how are the two things going to be cross-linked? What do you see happening in terms of configuration management for asset information management in respect to IFC 5.0?
So IFC 5. Oh, okay. So I mean, obviously they're really only started to develop that at the moment, and it is going to be a big change to the architecture of IFC. I know Greg, who leads the initiative, he's a big fan of USD. So I imagine there might be something in regards to that, or some, linkage with that within it. It's a bit quiet at the moment because of what they're doing, but I think what they're trying to do is modernize IFC, you know, for the future. And I personally hope it goes down, you know, the whole knowledge graph ontology route. For me, that's where it has to go. There are, you know, there is IFC OWL at the moment. How usable that is in terms of a web ontology language, I've heard good and bad with regards to that. So yeah, I think really it's just seeing the direction it goes. But for me, it's about having that common data approach, and if IFC is a solution to that, that's fine. I mean, if there's something else that does what IFC can do but better, again, that's fine. You know, I'm not absolutely wedded to IFC, but that's what we have at the moment. And for me, rather than keep bringing in new things, I think we need to start and actually use what we already have. And because otherwise we're never going to do anything, it's never going to be implemented on the ground. It always just stays at concept level. And people, you know, are on their daily business, they can't share information, and there's huge problems just, you know, with an architect sharing information with an MP engineer. It's, you know, that's the day-to-day problems we have. And you know, I just wish we, you know, everybody could just work together just for one to develop one thing rather than have so many competing things, which is just so confusing. So many standards in this space, and I can't even begin to explain how many we have that all overlap.
Yeah,
and it's like no one can make sense of them, especially, you know, people, you know, on the ground. So it's I think we just need again a cultural change, but we need to work together. We have to work together. We all have different pieces of the jigsaw puzzle. That's how I see it.
Yes, yeah.
I don't know if I should comment.
Tangent there, but
You should.
No, my biggest thing is, and you know, I have an incredible amount of respect been done in the past, and this is a crude awakening I kind of had. We're at a point where we need to understand what we have done, but the world, and I can be very clear about this, about how we're going to work in the future, is changing, and I don't know how to make that clear, more clear than that. We're at a pivotal point of human relation and work. It is going to change. And I think part of the problem, Emma, that you're explaining as well is very, very valid, is that there's been so much work being done. I'm at a point now where we actually have to pull the rug and look at things to go forward. For the first time ever, we have the ability to load 100 plus Revit files and mechanical files alongside robotic simulations, alongside CFD simulations, alongside full operational models, alongside the review of these things in a space to make decisions and to manage based on live data. We've never been able to do that before. And we cannot do that with current frameworks. We can consume those and build upon them. And I hear your pains 100%, and it's not against anything of so many standards, because I've lost, I don't read anything about ISO. I can't do that anymore. I'm focused about what we need to deliver and how to take it from concept stage to an operational model that not just is a digital twin, but becomes a switch on to synthetic data, to live data, so we can simulate and predict what's going to happen when we do changes, down to the point of speaking to firms that do accurate AI-based simulations of human behavior in cyberspaces. Put that all together in one. And now, how are we going to do that? Right? Because that's where we're going to. We are going to be able to simulate what we do so extensively that we're going to make decisions before we do it, and even while it's being built or operated, being able to predict situations. And if you look at densifications and humans inside spaces and traffic and movement, there's so many pushes and pulls from different technologies and different industries that's going to have to be in one space. There's no other way to do that. They have to be able to work. And this is my only concern, is that we are still looking at the problems we have in our space and trying to solve the problems in our space based on what we have done. And you kind of have to step over and see. That's my comment about the not being able to unseed, to see that there are a limitless space outside there that I can pull anybody from you involved and help me build something that will benefit cities and models and stuff like that. So it's I don't know how to put this more clear. I've unfortunately seen it, so it is kind of what it is, and it's very important because there's an incredible amount of work done in the past, and I'm not by any means saying we should stop or replace that. I'm saying, how do we bring it into a platform where we can actually get help from other industries and other formats and other schemas and stuff like that? So.
Yes, absolutely. Yeah, and AI as intelligent interface between all of different parts is quite transformative. I'm noting the time. Chris, you have your hands up. So if you,
I'll be super quick. So this is more in response to Dirk's point about OWL. It's this whole like undercurrent to these discussions that there's information, but is it representational or is it reasoning? And I think one of the problems with some of the legacy schemas is that they were very much focused on structured representation. And that's what made it difficult to programmatically reason by passing lots of instances of, say, a selection of potential components or potential methods to service one functional requirement. And like listening to Cobus and this shift in, shift in viewpoint, it's how do you best utilize the structures that exist? There is a huge issue with standards sometimes being contradictory, but the central thing I wanted to ask, if I may, and the time permits, is that some standards, they say what, but they don't necessarily give you rules of interpretation to reason how. And I wonder if the next steps of, say, ISC or any of these initiatives is going to move more towards a description of data which renders the rule base for interpreting how it should be used, and that's the thing that you feed into the AI or statistical distribution or machine learning based on population or frequency of use. All of these different strategies that exist to use computing to parse data sets, are they really reasoning, or are they just finding a best fit without really understanding what the representation, the data model is representing in a specific instance?
So I guess this is for Dirk, right? Chris or everyone?
I will try maybe to say something quickly. I don't have the answer, of course, but yes, so we find in older standards that reference data is presented there basically in some structured way, and it actually becomes quite difficult to take that information and put it in its right place, given an upper ontology that has been sort of designed carefully from a philosophical perspective. So you really have to be extremely careful about this. It is a relationship. So everything you look at needs to be looked at twice. And is it really categorized correctly? Is it really what we want to say here? Or are we actually misunderstanding a lot about the reference data that was put there in the first place? So we find examples of that all over the place. And we also find that it's very difficult to use existing standards in the reference data in this, in our ontology framework. It seems like we need to rework everything. Maybe AI can help in the future. Right now, AI is at best able maybe to do some preliminary kind of reasoning. It's very shallow. There is no, AI cannot do math, and AI cannot do philosophy yet, but it's getting better, I would say.
Yeah, that's a very good point. So we running a little bit over time. I've seen that Kian and Louise are online. I just would like to go around the table and just get some final thoughts and any final contributions to the session, any final comments or views, and then we can break away for lunch and come back a little bit later. So I start clockwise here from my screen. Emma, any final thoughts?
Yeah, I think for me, it's really just laying those foundations of information and kind of meeting, the AI halfway to help accelerate it, but on our terms rather than AI dictate. And I always get worried about when people start talking about Revit models and using them as the basis of AI, because I see Revit models on a daily basis and I know the data in them is not fit for purpose. So those things just worry me.
Okay, a provocation there. Okay. Cobos on my screen, you the next one.
Yeah, great. No, thank you very much, Abel. It's very exciting. My biggest thing is just keep your eyes open what's happening outside your boundaries. I mean, it's very, very important. Try to imagine what you would do in the practice in 2 to 5 years from now, because you're going to have to start working on getting ready for that, and how we really, my closing slide was really how we're really going to become better at our subject matter and better at the knowledge that we do, because of the assistance of production being taken away by AI. My underlying thesis of my talk is that I don't need to know 3D to be able to make decisions. I can actually speak to it in the way that I want to work with a computer. I think it's very important. The focus is like I said, not going from being a computer specialist, but from being a designer that is a human-centric designer, and the computer augmenting you, not replacing or doing anything else to that. So in your preferred method, keep an eye out in the future. So absolutely. Thank you, Abel.
Yes, absolutely. Yeah, very good point. And I could say something about that. That there is a very respected professor at UCL, where I am, and world famous, that he struggles to accept that we can just talk to the computer and get a 3D image, or you can take a few photographs and derive an entire scene, simply because it's so transformative. He sees all of this with a lot of suspicion, and because it is dramatically transformative and shocking what you can do with that. But there's a lot to be said about that. Yeah. So next one, Dirk Walters. Final thoughts, provocations.
I think yes. I think we're having the right discussion. We should have many more of those. And so thanks for this session and for this topic. I totally agree with Corbus. AI advances quickly, and we should be aware of these developments and not be overwhelmed by them, but rather use them wisely for the better.
Right. The next one on my screen is actually Luis from Magneto.
Oh,
You've been very quiet.
I've been not quiet in my own mind, but yeah, I mean, I think I have been part of EU projects where ontologies and schemas have been developed, and projects where ontologies and schemas have been developed. And, to borrow a term from my partner, Elizabeth, any industry at this stage is basically, a wicked problem to try to solve. And I'm not sure I see much evidence in putting our efforts right now and standardizing something that is yet to be resolved. I think, like Cobus, things are moving really fast. AI is also a nice distraction. I mean, it's important and it's going to be useful, but I guess with the same vein of putting efforts in developing schemas and ontologies and standards and things like this, I think we should also look at AI in the same vein. Like, is it actually going towards solving the problems that need to be solved? I guess that's my vague way of summing up what I'm thinking about right now.
It's very legitimate, but I think that a war between, classicistic mind and relativistic mind will always be there. Some people try to classify things and give it structure to everything. Some people just navigate the world in a relativistic way, and we kind of live in between those two things. I think AI, if anything, is going to give even more contrast to that, maybe. Yeah. Okay, next one on my screen is Chen-Ming Lee. Any thoughts? provocations?
Thank you.
Yeah.
Thank you for having me here. And I think actually, last year I'm working in HKU as a research assistant with Dr. Catherine Wu, and we also have a project, another project in AI controlled chair generation. So I have some after I working in practical architect firm in Hong Kong this year. And I'm actually working on a project manager position, and I indeed see some potential in for AI to not only in design position and also in more in project manage position. And AI is grow quite faster and also faster and faster. So actually, I don't see I don't know where is the answer exactly, but I inducing the potential of AI to do something in architecture.
Okay, so maybe you should come to the Bartlett and do a PhD, and then you can think about that. All right, no, that's I love your paper. Very beautiful paper. Thank you.
Thank you.
Professor Christopher Long, final thoughts?
Well, first of all, just to say again, an amazing set of presentations that's really thought-provoking and just forces us to reflect that there's what we'd like the world to be, and then there's the way it is at the moment, and we're stuck somewhere between the two, believing that the future is going to help us with computer augmented tools. But I think at the end of the day, it requires reasoning. They're great with representation, but what's the level of understanding? And I think that as anyone with a design background or a making background or a logistical or operations background, that's the heuristic. If you think back to the early stages of AI being great for chess computing, but really bad at natural language interpretation, and that's 30 or more years ago, and you fast forward to today and think forward, as Copus is pointing out, 5 years from here, it still requires reasoning. It still requires like a fundamental understanding of what's, AI as optioneering seems to be where we are. It's become very fluid, and that's great. But in some ways, some things get easier, some things get harder. But I get the impression AI is just making things faster. Thanks.
Yes. Yeah. No, that's yeah. It does give me some goosebumps and nightmares sometimes. But it is all. I think it's all for the greater good. I'm quite optimistic. Kian is there, but he has been quiet. I don't know if he's in transit, if he wants to say something. If not, then so I'll call for lunch break, and then we will be back at 1 o'clock. We overrun a little bit, but I think it was worthwhile. So I will be back at 10 to 1. And then we start at 1 with quite a few keynotes as well. And there's interesting, if you like AI, I think you'll like session 2. There's an interesting presentation from DeepMind. So thank you, everyone. I really, I feel very privileged to have you all here. I thought it was super interesting, and it's given me a lot to think about. And I hope to see you all again soon. Thank you very much.
Thank you.
Cheers.
Thank you.